So today we're going to talk about linear and quadratic functions today. Last time we learned that all lines are functions except what type of line? Yes, sir. Thank you for raising your hand. Yes? Vertical lines. So all lines are functions except for vertical line. Why? Because it passes the what test? Vertical line test. Good. Raise your hand. And who remembers what a function is? Why is a line except for vertical line? Why is that a function? Because anybody remember? Raise your hand. Yes, Ali. Yes, each input has exactly one output. That's why it passes a vertical line test, right? So a function defined this way is a linear function. We know it's a function. We could call it a linear equation, but now it's a function because this represents every line except for vertical line. Well, I kind of have to say that, so I'm going to write does not include any vertical line, which means m, we don't want m to equal to undefined. You know what I mean? So as long as m is not undefined, we know it's a function. So write this down. Question? Oh, okay. All right. So I'll give you time. Write it down. So, what does this mean? Well, whenever you graph this equation, what do you get? We just said it. We get a line. And write this down. So that means if the domain of this function f, if the domain of this function f is set of real numbers, then its graph is thus its graph is the straight line with slope of m, of course, and y-intercept of b. Remember that right, guys? This is kind of a summary of what we just talked about. If the domain of f is set of real numbers, right? What do you get? You get a. What's the graph of this function look like? Yeah, straight line. Straight line. Yeah, straight line. So we get a straight line with slope of m and y. Why is it that this is a function? Again, this is important. When you get a straight line that is not a vertical line, why is this a function? Yes, sir? Yeah, each input has exactly one output, and we could use the vertical line test to test. Every line other than a vertical line, right? It passes the vertical line test. Now, do you think all function then would, well, do you think all this function, do they have to equal to a line? Do they have to look like a line every time? The answer is no. It could actually look like a circle. Is circle a function? No. No, it's not. It could be a curve. So the curve that we're going to talk about is this. If a function g, I'm going to use g now because I just used f. A function g defined by g of x equals to ax squared plus ax squared plus bx plus c, where a can't be 0, is, does anybody know what kind of equation this was? You guys remember doing trying to factor this kind of equation and so forth? What do we call this kind of equation? Victor? It's a trinomial, but what kind of equation is this? Yes, Paul? Quadratic. It says right up there. It's all quadratic function now. And do you see why this is going to be called function? Because whenever you graph this, guess what? Set of order pairs will be a. Right. It's going to be this equation when you graph. It's always going to, each input will always have exactly one output. That's why we call it not a quadratic equation now. We could also call it a quadratic function. Okay? Because each input would have exactly one output. When I graph this, guess what? Do you think it's going to pass the vertical line test? Yes. Good. So this equation, ax squared plus bx plus c, if a equation has this form, by the way, a cannot be 0. Why not? What happens if a is 0? Chris, any idea? If a was 0, then not quite. If a happens to be 0, then it would not be a quadratic function. Does anybody know why? It becomes a something else. Yeah. No, it doesn't become a vertical line. Yes. It becomes a linear function. Because if this quadratic term goes away, you have basically b times x plus c. So instead of mx plus b, you have bx plus c. So what do you get? You get a line. Does that make sense? So that's why a has to be non-zero. If a is 0, then you don't have a quadratic term, you don't have a quadratic equation. Okay? Turns out then, we know that linear equation looks like a line. Does anybody know what this graph gives you when you graph this? One person? 2? 3? Okay. What does that mean? Raise your hand, raise your hand. Okay, William, what do you think? It's going to be a curve, yes, but what kind of curve? It turns out. Yes, sir? It becomes a parabola. Very good. What's a parabola?
Something that looks like this.
Right, but not always that way, but it is called a parabola. Write this down. The graph of G, if the domain is real number, is a parabola. Okay. Now parabola looks like a somebody like it's like a smiley face, or not. It's not always smiley face. It could be it could be sad face or fine. Yeah. So it could either look like this, going up. It's we call it opens upward or it opens downward. The sad face will be opening downward. Smiley face will be opening upward. Now, question. No. If it does sideways, is that a function?
No.
Yeah. So the sideways, we're gonna learn that later. So don't worry about that now. For parabola that has this form, g of x equals ax squared plus bx plus c, it will never be sideways. It'll either be a happy face or sad face. Do you understand? Do you understand? Yeah. Then it's not a parabola. It's either happy face or sad. If it has this form, ax squared plus bx plus c, it cannot be anything else other than happy face or sad face. Okay, does that make sense? Are we clear with this? Okay. Don't sometimes unlike I think a lot of you seen this on the test where they give you something other than happy or sad face, right? They give you some one that goes sideways or something like S, that's not a graph of a parabola. Okay? Now, how many people then when do we get a happy face? It actually depends on just by looking at the equation, you could tell whether or not you're going to get a smiley face or happy face. You might have learned this in intro. I'm not sure. Does anybody remember, Caitlin?
If it's positive, it's a happy face.
What is positive? You're right. What is positive?
I don't know.
Oh, you're right. If something is positive, you get a happy face. If something is negative, you get a sad face. What is that something? Yes, sir.
The ax squared.
ax squared? Kind of, yes. It's the a. Well, isn't the coefficient? Doesn't the coefficient make that whole term positive or negative? So write this down. If a, that coefficient of the quadratic term, we don't care about b and c, okay? If the coefficient of the quadratic term is positive, you get it opens upward. If a is negative, then guess what? You get a it opens downward. Mathematical term, it opens downward. Okay, so there you go. Write this down. So knowing this, guess what? We're going to try to then graph a quadratic function. So here's since I use f and g already, let me use h for this function. Is that okay? So here's h of x. X squared minus 6x equals to 4. And so if I want to graph this function, by the way, we know what it'll look like. Does anybody know what it's going to look like? It's going to be opening upward or opening downward? How about Victor? What do you think?
Upward.
It's going to open upward. Why? Why do you say that?
Because A is not negative.
A is positive. What is your A, guys?
1.
1. That's exactly right. Right? You don't see 1, but it's invisible 1, right? It's positive. So it's going to open upward. You're right. Now, how are we going to graph this? Well, do you guys remember how we graph lines before knowing all this slope-intercept form and anything? What sort of method did we use? Yeah, Stefan? Yeah, we plot points, right? We plug in points, and even though it may take a long time, guess what? That is a very, very powerful way of graphing because say it again. It's always accurate. You always know which point you could always plot point, right? Without really knowing anything about the function, you plug in your x and you get the y, and you keep doing it. You could always graph something, right? Even though it may take a little bit longer, right? So it's powerful because you could always plot these points without knowing much about the function. So here's our function. By the way, h of x, remember, is just y. Remember, that's another. So guess what I'm going to plug in first? Easiest number to plug in? 0. So here's my table. So I'm going to plug in 0. I'm going to plug in 0. Go ahead, everybody plug in x equals 0. See what you get. By the way, do you see how I did x comma instead of y? I did x comma h of x. Is that okay? Right. After all, what does h of x mean? Y. Okay. So go ahead, everybody find what I get for y. In other words, what's h of 0? You see how easy it is to say it now? Now that we know function notation, what's h of 0? Oh, you have a question?
Wait, so if you plug in the 0, would you plug the 0 into the h of x?
Right, so you're looking at h of x, so in place of x, you're just plugging in 0.
Okay, so
What do you get?
that's why I got
Hmm?
That's why I got
Oh, yeah, so h of 0, then you plug in 0 for wherever the x, wherever you see x, that's where you plug in 0, right? That's what we're doing. So what do we get? Hold on, what do you get here? What do you think, sir? Eric, what do you think?
you get
4. Very good. So we get 0, comma 4. Is that the part you're having problem? Eric,
yeah.
do you understand that?
Yeah.
Okay, good. Does this make sense, guys? Yeah. We get 0, 4. Simply that. Guess what I'm going to plug in next? 1. That's right. So Eric, can you, okay, everybody be quiet. Eric, can you tell me what you get? Go ahead, I'll give you time. What do you get? What's h of 1, Eric? Basically. Yeah, take your time. H of 1, you plug in 1 for x, so you get negative
1.
Correct. Very good. You get the idea, Eric? Yeah. All right, now, what I want you to do is, as a group, because I'm going to do a whole bunch of these. I'm going to go all the way up to, I think, 8. So, you guys, this group right here, can you tell me h of 2? Okay. This group right here, I want h of 3. You guys, tell me h of 4, h of 5, h6, h7, and h8. Go ahead. So, and then we're going to share the answer, yeah?
Are we going to have a test on the chart
Are we going to what?
Are we going to have a test on the chart?
Yes. Why wouldn't we?
Because we already had a chapter 8 test.
We had chapter 8 test already?
It says it there. Wednesday. Oh, that's the
20,
21st.
21st. No, not second. Okay. All right, go ahead. Okay, you guys, what did you get for h of 2? Tell me. 2 negative 4. Yeah, give me it as an order pair. 2 negative 4. Is that right? Okay, so the rest of you just copy it down. You don't have to copy the work, but you get the idea, right? Just write down the order pair, because I don't want you to all do the whole thing. Okay, what about you guys? What about h of 3? What'd you get? 3 negative 5 is correct. What about the other group? H of 4? 4 negative 4. Okay. What about over here? H of 5? 5 negative 1. You guys? What do you guys for 6? 6, 4. Okay, good. What about you guys over here? 7, 11. Okay. And over there? 8, 20. Good. Good. So I would like you to then see, it's nice kind of we did it as a group. So go ahead and write down these order pairs. And guess what we're going to do next? We're going to graph. Okay. So go ahead. Write it down. So pick a point from your group. You're going to come up and plot these points on the board. Okay.
With the one that we answered?
So before you connect them, you should have gotten, it should be a nice smooth curve like this. Okay? Well, but what, yeah, well, I can show you another one. But, right. Well, what I don't want you to see, what I don't want to see is don't just connect these dots, like make it kind of line segments, then it's wrong. Does that make sense? Because this graph gives you a nice curve. Okay, so let me actually do a better job. What was the equation? Wasn't it this one? There. Alright, so there's a nice smooth curve, okay? So it should look like this, okay? I did my best. By the way, so kind of imagine that's what this looks like. And notice it goes on forever, okay? Because your domain is all real numbers. I'm sorry? So since your domain is all real numbers, as you plug in more x's to the right and left, it's going to expand. It's going to get wider and wider, and it's going to go up higher and higher. Does that make sense, guys? Some person asked, hey, Mr. Huang, as you put in more x's, do they ever kind of cross? Does it become kind of like an oval? The answer is no. If it did, would it be a function?
No.
Why not? It would not pass the vertical line test. Does that make sense? Okay. So, everybody okay? You all have this graph? Okay. Anybody need more time? Raise your hand. Okay, I'll give you time. By the way, does anybody notice some other stuff on this graph that doesn't belong to this graph? Yeah, so I wrote down this vertex. By the way, guess what this point is called? Vertex. What's the order pair? 3, -5. Now, do you see this dotted line? That's not part of this graph. I just graphed this line because there's a name for this line. Does anybody know what the name of this line is called? It's a vertical line, but well, let me ask you this, by the way. Let me ask you this. Not a vertical. It is a vertical line. What do you mean? But this line, in terms of this parabola, is called a line of. So on your homework tonight, it's going to ask you this. It's called the line of. Well, actually, not. It's called the axis of. Sometimes call it the line of. But it's called the x. Write this down. Axis of symmetry. 2 M's. By the way, I should make this blue since I'm talking about this. Okay? This is called the axis of symmetry. Right, Gianni? Gianni, why do you think this is called the axis of symmetry?
Because it kind of divides them to 2 equal shapes.
That's right. It's symmetrical, right? This parabola. So it kind of divides this parabola to the left and right side of it, right? That's where the line of symmetry is. It divides this parabola in half, in other words. Does that make sense? Now, when we were doing this problem, we got really lucky because when we picked these random x's, it gave us nice sort of points, right? It didn't give us a bunch of points on the left side of the graph only, or it didn't give us points on the right side of the graph only. You know what I mean? It gave us a point where you got some on the left, you got the, most importantly, you got the vertex, right? We were able to find the vertex, right there. Does that make sense? And we were able to find some of the points on the right side of this. Question? So here's what I'm trying to say. On your homework tonight, right, would all parabola be at these, whenever you plug in like 0, 1, 2, 3, 4, and 5, and so forth? Guys, do you think it'll always get you the vertex? No, because you could. What if the vertex is at like 3.5, right? What if vertex was at 10? X equals 10. Now, how do you, right? So do you think when you're graphing these using order pairs, Ryan, do you think it's important to know where the vertex of the parabola is? Yes, it is. Because if you know where the vertex is, then it's going to help us to choose the wise numbers to plug in. In other words, you have to have the vertex to know which points to plot. And exactly, how do you then figure out where the vertex is? And of course, people have thought of this many times. Are you ready? This is the key concept of the day. Are you ready? To find a vertex, people have been working at this problem for many, I don't know, days, months, years. And they actually figure out this magical formula. They found that every time you have a parabola, either smiley face or sad face or opens upward or downward. Are you ready? Here's the fact. The x coordinate of the vertex, when you have f of x equals to ax squared plus bx plus c is, you ready? This. You just need to find negative of b over 2a. What is b and a? Well, does anybody know what b and a are?
X and Y intercept.
No? They're not the x and y intercept. In terms of this function, a and b are the anybody? Where did they get this a and b from? Yeah, in other words, these are the coefficients of your equation. Okay. A is the coefficient of the x squared term. B is the coefficient of the x term. So So this is a very, very important and valuable information, because when you do your homework tonight, guys, you don't want to just pick on any random points, because it will just give you, if you do that, it will just give you parts of the order pairs of the graph. It'll just either give you the right side of the parabola, it'll only give you the left side of the parabola, right? You want points that are on the right side of the parabola, you want the middle point, right? And you want the points on the right side of it. Yes?
If there's a negative here, but our problem was.
Oh, we'll get okay. We'll do an example. Give me a second.
Oh, okay.
So let's see. Okay, guys, does this make sense? Let's see if it works for our example that we just did. What was our equation? It was h of x equals to what? X squared
plus 6x plus 4.
minus 6x plus 4, wasn't it?
Oh.
So it was x squared plus, well, it was negative 6x plus 4. But do you think it's a good idea to write it as an addition now? Because it's this formula, right, is an addition. So what's your a in this one? 1. You see 1, the invisible 1. What's your b? Is it 6 or negative 6, guys?
Negative.
Yeah, because once you change it to addition, it's a lot more clear to see that it's negative 6. So a is 1, b is negative 6. Everybody go ahead and plug into this formula. See what you get. What do we expect to get? What was our vertex? X coordinate of the vertex. It was 3. Did we get 3? Go ahead, plug it in. I'll give you time. Plug it in. So, did you all get 3?
Yeah.
There, I plug in negative 6 for b. So, by the way, when you plug in, what should you use? Parentheses. So, negative 6, you plug in, what's negative of negative 6? 6. Over 2 times 1 is 2. There you go. You got the 3. Then this is your x coordinate of your what? Of the vertex. So therefore, some will be asking, well, so then, how do you find the y value for this? How do you find the y value for vertex? Do you know how to find the y value? Yeah. Yeah, you plug in 3 to your function. In other words, you find h of 3 is your y value. All right? Some of you ask, well, how many points then do we need to use for our homework? Do you think having 2 points will get you this parabola? No. Okay, once you find vertex, guess how many points you're gonna have? Do you think 3 will be good enough? No, 3 you get a V. I don't want you to draw a V. Okay, it's a smooth curve, remember? Guess what? You're gonna need 5 points. 2 on the left of vertex and 2 on the right side of the vertex. So when you do your homework tonight, here's the table you're gonna do, right? If I know that my 3 is going to be my vertex, right, which is 3 comma h of 3, isn't that my order pair? Well, I want you to use 2, 1, left side of 3, and 2 points on the right side of 3, which is 4 and 5. Does that make sense? Easy enough. If you didn't know this, guys, you're gonna get only right side of the vertex, parabola, or left side of the parabola. And when you try to graph it, you will just get like a line, a curve, part of it. You know what I mean? You won't get that nice smiley face or sad face. You know what I mean? Is this clear? Do you know what to do now for tonight's homework? This is the kind of thing they want you to do on tonight's homework, okay? Any question?